Welcome to the Walton Pi. Today we're going to be going through some examples of infinite limits and computing them. Alright, so let's show that the limit as x goes to 3 of 7 over x minus 3 to the fourth is equal to infinity. So because we are trying to show that this limit is equal to infinity, we are going to be showing that for all capital M bigger than 0, let's not use symbolic notation. So we're going to show that for all m greater than 0, there is some delta greater than 0 such that if 0 is less than the absolute value of x minus a, in this case 3, is less than delta, then f of x, in this case 7 over x minus 3 to the fourth, is greater than big M. That is what we are going to try and start with. So we are going to start with this and figure out what delta to choose. So we are going to have 7 over x minus 3 to the fourth is greater than m. This tells us that 7 over m is greater than x minus 3 to the fourth. So let's take the fourth root of everything. So we get the fourth root of 7 over m is greater than the absolute value of x minus 3. So we are going to say delta is equal to the fourth root of 7 over m. So in our proof we would say for any big M greater than 0, let delta be equal to the fourth root of 7 over m. Then, if 0 is less than the absolute value of x minus 3 is less than delta, being the fourth root of 7 over m, we have absolute value of x minus 3 is less than the fourth root of 7 over m, which implies that x minus 3 to the fourth is less than 7 over m, which tells us that m is less than 7 over x minus 3 to the fourth. And that would be enough to show that the limit as x goes to 3 of 7 over x minus 3 to the fourth is actually equal to infinity. Let's do one more problem together. So let's say that we are trying to show that the limit as x goes to negative 2 from the left of 1 over x minus 2. Let's try and show that that is going to be equal to 1 over x plus 2 from the left, that is equal to negative infinity. Yes, that is going to be what it is. So this is going to be a little bit different than the last one. We are still going to show that for any big M, well, in this case, since we're going to negative infinity, it's going to be any big M less than 0, so any large negative number. There is some delta bigger than 0 such that we have x minus negative 2, so x plus 2. Since we are only approaching it from the left, we only care about the numbers smaller than it. So we have 0 less than delta for x less than negative 2. So this is because the reason we have this less than is because we are approaching from the left. So if x is less than negative 2, absolute value of x plus 2 is going to be positive, but x plus 2 is negative, so we can rewrite this as 0 is less than negative x plus 2 is less than delta, because that's what the absolute value is when x is less than negative 2. So we are then having, so it's such that if this is the case, then 1 over x plus 2 is more negative than m, so m is going to be bigger than it. So that's what we are going to be dealing with. So starting with the 1 over x plus 2 less than m, we can use this inequality that we have right there to be able to say that this means that x plus 2, if we multiply everything by negative 1, is smaller than 0 and bigger than delta. So we can take this 1 over x plus 2 is less than m, that becomes 1 over m is less than x plus 2. And so x plus 2 is bigger than 1 over m, x plus 2 is bigger than delta. We are going to say that delta is equal to 1 over m. However, oh, whoops, I forgot a negative right there. So there's a negative, so delta, so negative delta is equal to 1 over m, so that means delta is negative 1 over m. So in our proof, we'll say that for any m less than 0, so any large negative m, let delta equal negative 1 over m. Thus, delta is greater than 0. So we needed that condition for delta, and now we have delta is bigger than 0. So what we are going to have is we say let x satisfy 0 less than the absolute value of x plus 2 at less than delta equaling negative 1 over m for x less than negative 2. Then the absolute value of x plus 2 is equal to negative x plus 2. So we have negative x plus 2 is less than negative 1 over m. So that means that x plus 2 is greater than 1 over m. So m is greater than 1 over x plus 2, which is precisely what we needed to show. So that means that the limit as x goes to 2 from the left of 1 over x plus 2 is equal to negative infinity. I hope you enjoyed this video and that it was helpful for you. Please check out some of my other videos, and please like and subscribe if you have not already so I can continue to make these sorts of videos. Have a great day and good luck with the rest of your math.